All right, so solving absolute value equations. This says 1.4. I kind of skipped this. I skipped chapter 1, so I'm just adding this, the 2.7, where we were graphing absolute value equations. But the absolute value of any number is the distance from 0 on a number line. Since the distance is always non-negative, absolute values are always non-negative. That's our absolute value symbol. Should be familiar by now. Some people like to think of an absolute value as being a positivity machine. Basically, if you put something into it, you're always going to get a positive outcome. And just kind of recall, if you want to, like, I mean, I'm assuming most people are pretty good, but the absolute value of -2 would be 2. The absolute value of +3 would be 3. You could always draw a number line and look at the distance from 0, but that's really shouldn't be necessary. But you would see 3 is 3 away from 0. -2 is +2 away from 0, because you can only have a positive distance. Okay? One thing we're going to start with today is we're going to practice evaluating or plugging in, say, a possible solution back into our equation, because one thing with absolute value equations is it's pretty important to check your solutions. I'll kind of explain when you need to do it, but one thing that can happen when you solve absolute value equations is you can actually get an answer that's basically a false positive. Like if you plug it back in one of your answers, you'll see it's actually not true. So if you're not careful, you might get a solution that's not really a solution to your original equation. So plugging in and checking your answers is actually really important for absolute value equations. And I'll kind of give some tips like when you need to do that. But I know sometimes like your teachers always say you should check your answers, and you're like, yeah, I agree, but you don't do it. But for absolute value equations, it actually is something you really should be doing. So for example, this example A, if we're going to evaluate -2, that just means plug it in. So this is something I just want to make sure we're pretty comfortable with. And I'm just going to change 3.5. I'm just going to make that 3.5. I'd rather have a decimal than a mixed fraction myself. So if we evaluate this, and sorry, this is an absolute value bar, kind of looked like a parentheses. So if you work this out, your inside, you would have -8 plus 3. So you'd really have the absolute value of -5 minus 3.5. Sorry, I'm writing a little bit big, but so the absolute value of -5 is +5 minus 3.5. So my answer would be 1.5. How about you guys take a second, see if you can evaluate this second expression for -2. So see if you can evaluate this. Like, what is this going to equal? So take a second, and if you get your answer, how about in the chat, if you can. My chat's like hidden right now. Let me see if I can find it. But in the chat, see if you can, if you could send me your answer so I can see how we're looking. Sorry if I was moving my screen. I don't know if that moves it for you. Okay. Some people did it quickly. And just FYI, when you're checking your solutions in the future, like in an equation, like if this was like a quiz, I don't need to see your work of you plugging it back in, like if you're just putting it in your calculator. But if it's helpful to write it out like we are in these examples here, definitely do that. But just so you know, like in the future, if I was giving you an equation and you were checking your answers, like I don't need to see you plugging it in, but you should definitely be doing that. Said through nothing, but a lot of people sent me the answer. You should have got -2, which is good. Most people were sending me that because this would have really been 5, because 3 minus -2 is 5. So -2, that would be times 5, because your absolute value +5 is just 5. So if you work this out, you should get -2. So most people that sent me an answer looked good. But like I said, this is going to be in kind of, I just want to make sure we're comfortable with this, because for some of these equations, you definitely want to plug in your answer and check. And I'll explain how you can know if you need to check your answers or not, so you can save a bit of time on your Delta Math today. But let's look at actually solving today. So solve an absolute value equation. So there's this fancy term. Honestly, I've never heard of it until I came across it in this note sheet, but it's called bifurcating. Basically, we're going to divide our equation into two different branches. What a fun word. We're going to be bifurcating all day today. So basically what that means is, because when you solve an absolute value, if you think of a number line, like if we're looking at this first example, we want to think about what would make the inside of this absolute value equal 3. Well, there's really two ways you could do that. You could be 3 to the right of 0, or we could be negative 3 to the left of 0. So I want to figure out what I can make the inside of this absolute value equal positive 3 or negative 3. Because there's really two ways to have an absolute value equal 3. So we bifurcate. I hope that's how you say it, bifurcate. I've never seen that word. It makes me laugh though. All right, so you basically write what's inside your absolute value and you keep it equal to the positive of the right-hand side. And then you write the inside of your absolute value and set it equal to the negative of the right-hand side. That word, it does sound kind of like a nasty word, like but it just means to split up your equation. Yeah, I'd be careful who you say you're bifurcating by. They might get the wrong meaning of what you're doing. But then once you've got your two equations, you just solve and you'll get your two solutions. So we would get x equals 8 and you would get x equals positive 2. And you would see if you plug this in, for example, 8 minus 5 would be the absolute value of 3. So it would equal 3, it's true. If you plugged in positive 2, you would see you get negative 3, which the absolute value of negative 3 is also 3. So if you check these answers, you should see that they are true. But let's jump into some more. I'm not going to worry about sketching the number line. Basically, you would just put your points on the graph. So you don't have, I mean, you could do it if you want, but you won't have to do that in Delta Math. So if you already have the absolute value by itself, you're just going to set it equal to the positive. You're going to set it equal to the negative. So, and then just solve these equations. So I'm just going to write my answer down here because I'm running out of space, but you would get positive 3. You would get x equals negative 9. And you could plug these answers back in. For example, if you plug in 3, you'd see the absolute value of positive 6 equals 6. If you plug in negative 9, you would see the absolute value of negative 6 is also 6. Sorry if you were working ahead. I'm going to switch this problem because you're going to see in Delta Math, they're going to give you a little bit more stuff in your equation. So I want to give you an example that's hopefully more similar to what you'll see. So I'm going to change this problem. We're going to have 2 times the absolute value of x plus 2 minus 3 equals 3. So if you don't mind just crossing that problem out or just doing this problem I wrote. I just want to make sure you see a wide variety of problems in these notes. Both of these were pretty simple. All right, so if you've got an equation like this, see how we have all this extra stuff? We've got this 2, we've got this minus 3, and then we've got our absolute value. Before you can bifurcate or split up your equation, you want to get your absolute value part by itself, or you need to isolate your absolute value. So basically, we want to solve, or we want to get this piece by itself. So you're almost going to solve it like you would an equation. You're just going to add your 3. So then we would have 2 times the absolute value of x plus 2 equals 6. And then here's a common mistake students do. This 2, you can't distribute the 2 into the absolute value. That only works for parentheses. So don't distribute the 2. Don't ever be distributing when you're solving these absolute value equations. That's a very common mistake I see. But since this is 2 times that absolute value, we're just going to divide it to the other side. So we would have the absolute value of x plus 2 equals 3. Now we're ready, now that we've got the absolute value by itself, this is very similar to question A. Now we can bifurcate, or we can split up our equation. So we would have x plus 2 equals 3. We would have x plus 2 equals -3. So just solve these basic equations. You would get x equals 1. Subtract the 2, you would get x equals -5. And sorry, I'm running a little bit out of space, so I'm just trying to squeeze it in. But make sure you get your absolute value part by itself before you split up or bifurcate your equation. Okay? All right. One thing I want to talk about, I didn't see any of these in Delta Math, but one thing you could see, it's possible to have no solutions with absolute value equations. Basically, what you want to be on the lookout for is, since an absolute value, when you plug a number in, can only be positive, if you ever have an absolute value equation set equal to a negative number, you're just going to write no solution. You don't have to do any work. So for example, this equation here would be no solution because you can't have it equal a negative number to start. That's a no-go. Sometimes it might not equal a negative number, but say you're getting it by itself. Say you're starting to solve it and you get your absolute value part by itself and it equals a negative number, no solution. You won't see these in Delta Math, at least from what I saw, but just be on the, it is possible to get no solutions for absolute value equations. So if you ever have your absolute value part equal a negative, you don't have to split it up, just write no solution. The last thing I want to talk about is extraneous solutions. So I kind of mentioned these early on, but it's when an absolute value expression is set equal to an expression containing a variable, extraneous solutions may be encountered. So an extraneous solution is basically an extra solution that's not true. I like to think of it as being like a false positive. Like sometimes like in the medical field, like if you ever get like a test for a disease, like maybe I was getting a test to see if I don't know if I have COVID. Let's say I went and got a COVID test. It's possible, even if I got my results back and it said I was positive, it could be a false positive. I might not actually have the disease. So depending on the accuracy of test, sometimes you can get something called a false positive. But most of the time the tests are usually reliable, but that's why sometimes you want to be careful. You might want to get tested more than once, just in case you did have a false positive. But that's a different subject, but that's more of a statistics concept in terms of false positives, like on medical tests. But that's an interesting thing to think about. But anytime you have an equation, an absolute value equation where you have variables on both sides, and we'll see if you're working on your Delta Math, this will be in level 2, you can get extra solutions. So you want to make sure once you get your answers, you plug them back in and check. But this only can happen if you have variables on both sides to start with. So in this problem, here, I'm going to erase what I just underlined. We're just going to get our absolute value expression by itself. So I'm going to add the x. So I would have 4x minus 4. I would divide that 2 to both pieces. Got it right, too big. Now we're ready to bifurcate our equation or split it up. Do be careful. Basically, you're going to switch the sign. You multiply the whole right side by, well, the first one you just keep it the same. But for like the negative branch, you're going to change the signs of both numbers, or you would multiply the whole side by -1. So that positive 2x would be negative 2x, and the minus 2 would turn into a plus 2. You switch the signs of everything if you have more than one piece. Then we just need to solve these. I'm running out of space because I can't go down. Oh, I can't. I got space. Oh, thank goodness. I was getting stressed out. So you just solve these equations. I usually deal with the x's first myself. But for this first one, you would get 3 equals x. For this one, I'll add the negative x over. There's different, I mean, you could solve these in different ways, but as long as you get the same end result, that's fine. I'm sorry, I know I'm going a little bit quick in this part here, but I'm assuming most people can solve equations like this without too much issue. But these would be our two answers, but we need to check them because it's possible one of these is extraneous. So I'm going to start with the 3, and you want to plug it into the original equation. So if I plugged in 3, I'd have this. And plug it into like all the variables on both sides. So our question is, does this equal the same thing? So this would be 2 times the absolute value of 4 minus 3. This side would be 9 minus 4. So this right side would be 5. This side, if I work it out, well, 2 times the absolute value of 4 would just be 8, minus 3 would be 5. So you see this one works. So this is a true solution. Let's check the 1/3. And I'm just going to erase this, sorry. I'm just running out of space. So we're going to plug in the 1/3. So that would be 1/3 plus 1 minus 1 equals, oh wait, minus 1/3 equals 3 times 1/3 minus 4. So if you work this out, this would be 2, this would really be 4/3, like 1 plus 1/3 minus 1/3. This would be 1 minus 4. Sorry if this is getting kind of messy. This would be -3. If I work this out, that would be 8/3 minus 1/3. But clearly it's not the same answer. Like 7/3 is not going to equal -3. Like even if you kind of realize like it's not going to be the same. Oh yeah, I can scroll down a little bit. I'm sorry. But hopefully, like if you just take my word, if you plug it in, like even if you realize like the right side is going to be negative, the left side is going to be positive, like it's not the same answer. So since this is not true, we cross out this answer. So our only answer to this equation is 3. That's the only one that will make this true. So like in delta math, you would just put this answer in. You wouldn't put in the second one. And this question was a little kind of tough because we got a fraction as one of our answers. I'm pretty sure in the problems you'll be working on today, you'll only get whole number solutions. So you won't be plugging in fractions like we just did in this one. I know that can be kind of rough. So this took a little bit longer than I thought it would.